Hello guys, how are we doing? So I'm going to be starting by introducing you to this course and these series of tutorials that I'm going to be doing. And what I'm doing is I'm teaching Rust, and everything I'm doing you can find on the Rust website. Alright, so I'm taking their exercises that are done on the website, and I am going more in depth into answering the questions, solving it, and also helping you solve them on your own. What I'm going to be doing is I'm going to be explaining the first of all the general concept. Then we'll solve a problem, and then I put one out there for you all to solve on your own, and a few more so we can get familiarized with the concepts. Alright, so let's go. Now we're going to be looking at variables. We'll look at variables and things that make up variables in Rust. Let's start. So variables in Rust are like little boxes in a super organized room. Each box can hold different things like numbers, words, or even complex data. Now, what are some of the characteristics of variables? Now, we know that each variable, as we said, is like a box, so each variable has a label. And now this label is going to have a special name that is like my age or my favorite color, and this label helps you remember what's inside the box. So moving on, we have the contents. Now these are things that you can put inside the box. Now for instance, you can have, if the box is labeled my age, you can have maybe a number put inside of it, and the number follows the same pattern. I'm assuming we all know about the Rust syntax, and maybe you've at least gone through some Rust documentation, so you should be familiar with it. So you have some syntax or some numbers, and know if it's 13, like we have over here. If it's 13, it's going to be labeled as an integer type. You know, an integer type is, let me just change that. It's I32. You can now say x is equals to, let's say, a number 13. And this is how we set an integer type in Rust. I'm hoping that everyone is familiar with how this is done. Moving on, we have another type called the changeable type. And like I was saying, another characteristics of the variables in Rust is that they are changeable. So you can have something like an integer type that is 14, but you can change it. Like you can use the mute type, and I hope we know what the mute type means. The mute type means you add this MUT, right? You type this out, and that means that whatever you've put in before can be changed. Excuse me, it can be changed. That means it's mutable in Rust. And what normally happens is in Rust you have immutable data. That means the data cannot be changed. But when you add this MUT, right, it just means that whatever was there can now be changed. And finally, we have a type. Like I said, you have an integer type, you can have a string type. There are many types of types in Rust that you can have that will help you define what your box, in this case, is all about. So, without further ado, let's go into the problem that was given to us. So this is the problem we were given on the Rust website, and it has to do with binding and mutability. So it's the first, and this one has to do with initialization. So the instruction reads, a variable can only be used if it has been initialized. Now one of the comments in it reads, fix the error below with the least amount of modification to the code.
I'm looking for my plates.
Now the first thing we have to do is we have uninitialized and unused, and we have let me demonstrate what I mean here. So we have the uninitialized and unused. That's with this one. right here, uninitialized and unused, and then we have the one that, sorry, uninitialized and used, while we have the uninitialized and unused. That is y, right? And it's only going to give us a warning. So what we need to do here is that we need to show that x is equal to 5. That's basically what all this code, this long grammar is talking about. So let's try. What are we going to do? So the first thing we can do is we can say let x, right, that is a 32-bit integer, be equal to 5. And then we stop it at the end. That just shows that that's the end of our code. So how is this going to look in Rust code? So let me just try typing it out so we can all see. Just going to wipe this off. So in Rust code, it's going to look like, and you can type this in. The good thing is you can type this into the website and it's actually going to go through and it's actually going to run. So you say let x, that is, sorry, let x, hold on, let x that is I 32, that's a 32-bit integer, be equal to 5. And let's put that into the website and see how it runs. Like I was saying, this is the Rust website. This is Rust practice, right? Practice.rs. You can check it out by yourselves. I'm hoping that we all do. So the first thing you want to do here, like I said before, is say that this 32-bit integer is equal to 5. And that's just telling Rust that where x is going to be equal to 5, because here we have a macro that says assert equality for x and 5, right? So what we're doing is we're simply saying that x, that is the 32-bit integer that we have already initialized and assigned the value 5 to, is equal, and we're saying that x is equal to 5. And if that is true, print line success. So we can try this and see if it's going to run. Alright, so it's a success. So that's done. Alright, so this is our problem. Our problem is to write a Rust program that declares two variables, a and b, of the type I32, that's a 32-bit integer. We are to initialize a with the value 10 and b with the value 20. Then we are to print the sum of a and b to the console. So let's go inside the Rust playground and let's see how that goes. So what we're going to start by doing is by entering a question, and anytime we want to initialize or start anything in Rust, it's best to always start with this. Normally this is your default. Every time any Rust console or any Rust playground that you open is going to have this, but I take it away just so we can see it. I'm going to have fn main with the empty brackets. I like to imagine that the empty brackets are almost like giving it the potential to do anything. Then start with the curly braces. Then we say let a that is a 32-bit integer, that is I32, that's a 32-bit integer, be equal to 10. And then we tell that that's the end of the line. That's what the semicolon is for. Then we go to the next line. We say let b that is also I32, that's a 32-bit integer, be equal to 20. Then we use a semicolon to close that. If we don't use a semicolon and we go to the next line and we just keep on typing, it's actually going to read the next line and the preceding line as all just one line. So then we say to compile both of them, to make the sum of both of them, we say let sum, that's how we do it, let sum be equal to A plus B, and then we end it. That's to calculate the sum of A and B, and we are to print the sum of A and B. Then we use the print line macro. Print line, and we put the exclamation point. Print line within the, now when it's within the quotation marks, this is actually what is going to be printed, what we're actually going to see. And then we say the sum of this, that's the curly braces, and another curly braces, is a colon, and give some space, curly braces. So what we're doing is, these curly braces are sort of the potential openings for our answers. That's how I understand it. The potential openings for our answers. And so we say A and B sum. Alright, and then we end it there. Use a semicolon to end that line of code. So that's why we say that's how it's supposed to be. And this A, it goes into the first one, goes into the first curly braces, then the B goes into the second curly braces, and we say that the answer is supposed to go into the third curly brace. So what we're telling the compiler is that A and B are going to be in a sum. So let's see how that compiles. We run. So there are 4 major areas of focus when it comes to prevention of cardiovascular disease. Alright, we have no error, so we can confidently say that that is how you run the code. And that is our understanding of variables, the initialization, and the mutability. We'll go more into the mutability in the next lesson. Goodbye for now.